Imagine you've just finished a cool, refreshing swim in the Brazos after being sick for a week. You notice a tiny scratch on your arm is now swollen, red, and your arm appears grayish black. You clean it up with some hydrogen peroxide and take some antibiotics that your doctor gave you, thinking it'll go away in a week. Then, a week later, your arm is completely swollen, the skin is falling off, and now your arm is going to be amputated simply because an antibiotic is not available for the Aeromonas salmonicida bacterium. Therefore, as a result of the ACU microbiology research team's extensive study of the waterborne bacteria, A. salmonicida, positive consequences concerning the pelvic health and the aquatic environment is at hand. With complexities of microbiological research, condensed terms that make one's head want to explode. I know the first time in the lab when I heard all these terms, I was so confused. Therefore, I will briefly define these terms and their functions and describe the veracity of my bacteria. Then I will discuss the research process I utilized, and finally I will share with you the consequences and the benefits of my research. Some of the main terms I use extensively are SOPCR, or splice overlap extension, polymerase chain reaction, DNA polymerase, TAPY1 gene, and electrophoresis gel. According to Dr. Jennifer Huddleston, professor of microbiology at ACU, to visualize the function of a SOPCR, imagine sewing a bunch of little pieces of thread together to form a helicase ladder. DNA polymerase is a nifty little guy that breaks apart DNA so other enzymes can go in and help replicate it. The TAPY1 gene is the gene I'm working with that allows my bacteria to grow little tiny hairs that grab DNA from its environment to incorporate it into its own so that way it can become a superbacterium. Finally, electrophoresis gels are gels that I use to run my DNA down a gel in order to determine the size via an electric current. Now that I've hopefully given you somewhat of an image of what these terms mean, I can describe my bacteria. The Avicenna Journal of Medicine says that Aeromonas salmonicida is a rod-shaped bacteria that causes gastrointestinal illness, soft tissue infections, pneumonia, and meningitis, along with other nasty infections. In addition, the journal discussed the fatality rate of Aeromonas infections being at an all-time high, since almost 73% of those infected die. And this is because there is a lack of treatment, since this bacteria is resistant to most antibiotics. Since A. salmonicida is so competent, meaning it is good at taking up things that allow it to become even more resistant, Dr. Huddleston says this presents a large need to continue the research I am about to discuss with you. The research process involves a daily ritual of following the protocol established by Dr. Huddleston, along with several other microbiology researchers in her postdoc study of 6 years. First, we run an initial PCR to make the products for the regions in my TAPY1 gene. We'll call these products A, B, and C. Once we have done this, I run a gel to determine the size of each product, which is usually about 500 to 700 base pairs. And this for a DNA fragment is really tiny, so it is important that my amplification, or the replication of these DNA, is accurate. Once I have run the gel, if it is in line with the right size, then I can purify each DNA product using a centrifuge that rotates at 8,000 rotations per minute, or 133 revolutions per second. That is extremely fast and allows the DNA to be as pure as it can possibly be. Once I have all three of my products purified, I next use the SOPCR to tie or literally sew products A and B together. Then I repeat the gel with the product AB and see if it is about 1,000 base pairs. And if that is true, then I can purify my product AB, again using the same centrifuge technique. Once I have product AB, then I can sew product AB to product C. And this will allow me to eventually use this gentamicin cassette for this gentamicin antibiotic and eventually insert this into an Aeromonas sample. However, to this day, I still have not been successful in producing product A, B, C because there are just things that are out of our control, and we are looking into the processes and the techniques we are using in order to see if something needs to change. If that works, next we can get a pharmaceutical company to use our research to manufacture a gentamicin antibiotic to use against this voracious flesh-eating bacteria. However, as the Avicenna Journal of Medicine states, while some Aeromonas are susceptible to a wide range of antibiotics, they are universally resistant to penicillin, ampicillin, carbenicillin, and cefazolin, of which are the most commonly prescribed antibiotics. Unless my research team can uncover the secrets of the A. salmonicida genomic tendencies, early surgical exploration of this life-threatening wound is the main option for a chance at life, with only a couple of antibiotics that may or may not work. In conclusion, A. salmonicida is a nasty little booger that can kill anybody who has been exposed to it, be it through swimming or eating contaminated fish. And nobody should have to lose a limb or die again from this microbial monster. So one day, within the next year or so, with God on our side, we can lend a hand to pharmacists to develop an antibiotic so that way you don't have to. Thank you.
It's supposed to